Hi guys, how are you? Now I am fit, now I am a bit fine, and yes, so I am live. You can see me live. Let me see, like, if my yes, now it's fine. I'll just sit in this posture. Yeah, right now you can see me, correct? It's freezing in Delhi. You can see, right? Cap and mufflers. I just removed my muffler and it's freezing here. Let's get started. Just give me a moment. Yeah, so let's get started. What are we going to do today? We will be starting with the coordination compounds. This is a new chapter that we are going to begin with. Okay, this is coordination compounds, or you can say complex compounds. Okay, so before starting, you guys already know that. Hi Chetna, how are you, biche? Hi beta, how are you? I hope that you guys are fine, and you already know that we are going to ace in your term 2 examinations with Unacademy Plus. Okay, without I will let you know about the offers and deals later on. Let's get started with the class. You guys know me already. I am your chemistry educator, Kirti Sharma, and I have done my graduation from University of Delhi. And here now I am in front of you. Hi Netik, nice name beta. First time you are in the class, I believe. So without delaying anything, let's start with coordination compounds. You can see here we are going to start with coordination compounds, and these are also called as complex compounds. These are also called as complex compounds. All right, so this is a new chapter that we are going to begin with, and this is our lecture number 1. Okay, this is our lecture number 1. So without delaying, let's get started. Now, as we always start our no, Chetna is not new. Chetna is my permanent student, right? Chetna is my fixed student for YouTube. All right. Okay. So every time we start a chapter with applications, with the, I would say, how we use that particular concept, that particular chapter, in our daily lives. That is, for me. Okay, Netik is from UP board. Okay, Netik, that's great. So you must have seen me in the UP boards category before ISC category, I believe so. All right. So as I was talking about, that for me it is very necessary that I know whether, like, what are the uses of a particular concept, of a particular chapter in our daily lives. So here we are starting. Okay, Netik, that's great, that seems nice. Now we will rock in chemistry together. Okay, I will wait for you in the special class for chemistry. Okay, you can unlock the class by my code. You know this already, that this is Kirti S Live. This is my code. I know about Chetna. Chetna has ICSE boards. This I know. Okay. So yeah, let's start with the applications. So you guys already know that like the blue color, which is like shown here on the screen, it is still called as royal blue color, right guys? Now why this blue color is termed as royal? What is the reason behind it? So the reason is, from the source you obtain that blue color. In earlier times I'm talking about, it is a coordination complex, it is a coordination compound. We will talk later what are coordination compounds, but for now, like, we'll just understand that these blue color was very difficult to extract. So that is why it was very busy, and that was a coordination compound. It is also called as Prussian blue color or royal blue color. Okay, so as you can see, some more uh, applications of coordination compounds. So we discussed in D and F block elements. We discussed in D and F block elements that these elements, your transition elements and your inner transition elements, they form coordination compounds. Do you remember, Chetna? We discussed this, that they form coordination compounds, right? We knew the reason, that they have large number of unpaired electrons and all that stuff. We know the reason, correct? So we know that your D and F block elements form coordination compounds, and these compounds are colored. These coordination compounds are what? They form colored compounds. We discussed this, right? That they form colored compounds. So most of your coordination compounds are colored. They are found in a rainbow of colors: red, yellow, blue, orange, green, blue. They are found in different variety of colors. So that is why wherever we want to we want our stuff to be colorful. Okay, whenever we want to dye our clothes, or you can say for colorations, for dyeing, for pigmenting, these are the different terms you use for coloring something. So coordination compounds, you can see on the screen that coordination compounds have specific color. Therefore, they find a common place in industries of intense colorations. जहाँ पे भी आपको coloring करनी है, जहाँ पे भी आपको dye करना है चीज़ों को, there you generally use your coordination compounds. For example, phthalocyanide. It is written here, phthalocyanide. It is a class of coordination complexes जो कि बहुत ज़्यादा यूज़ होता है in dyes and pigments. Industry extensively use. They use it to impart specific colorations to the fabrics. What do we mean by fabrics? Simply जो कपड़े होते हैं, right? Cloth. बचपन में you studied na from fiber to fabric. It is the same stuff. Okay, right. So this is your first application, colorations, or you can say dyeing or pigmenting. Now another use is very interesting. Like our body has blood, that's plasma, right? It contains hemoglobin, right? It contains hemoglobin. We know already that our blood has hemoglobin, correct? That's why our blood is red color. So now this hemoglobin is nothing but a coordination complex. So not just in industries, various biological compounds are also coordination compounds. Okay, for example, you have done this in your junior classes, that chlorophyll is required for photosynthesis. Now this chlorophyll, which is a green colored pigment, right, which is important for photosynthesis, it is also nothing, it is also your coordination compound. So these are the biological compounds, and a lot of compounds which are complex, they exist in our body as well. Okay, and vitamin B12, which is essential for us, it is also a coordination compound. So what do you think these are? These are nothing but complex compounds. Okay, Chetna, Netik? Cool. So another thing, what we discussed till now, that your coordination compounds, your coordination complex, they are used in number one, colorations. Whenever you want to impart color in the fabric, or like whenever you want to dye something. Second, we did in our biological compounds, right? Hemoglobin, chlorophyll, vitamin B12, and a lot more. Okay, these were just the common examples which you all know. So these are nothing but coordination complexes. Okay, next is in the extraction of metals. So your coordination compounds are used whenever you want to extract some metals from their ores or from the minerals. Okay, so there we use extensively we have extensive use of coordination compounds. Okay, so you can see here as it is written on the screen that we apply the concept of coordination compounds in the extraction of metals from their ores. Frequently these days, extraction of nickel and cobalt involves uses of these compounds. These metals are extracted by hydrometallurgical process requiring a lot of complex ions. Why so, Netik? Like because of language or because of content? Like what is the reason? Is it because the mode of delivery is like in English only, or you did not get the concept? Because right now we are just going with the basic stuff, like how it is used in general life. Chetna, are you facing? Okay, Hindi, beta. Actually, Naitik, we are like for this ISC category, the batch जो batch launch हुआ है, this batch is only for English medium. Like we can talk in English only. The mode of delivery is in English, Naitik. I'm really sorry, beta. See, but I always suggest you one thing. हाँ, आई गॉट इट नैतिक, मेरे को आपका पॉइंट समझ में आ गया कि आपको चाहिए कि मैं एक्सप्लेन हिंदी में करूँ, राइट? बट अकॉर्डिंग टू दिस कैटेगरी माई मोड ऑफ डिलीवरी, कि जिस लैंग्वेज में मुझे बात करनी है वो मुझे इंग्लिश प्रोवाइड किया गया है, बिकॉज there are a lot of students from south Tamil Nadu, Kerala. So those students don't understand Hindi. That is why the mode of delivery is in English. Chetna, do you have the same issues, bache, or are you okay with it? Let me know, Chetna, if you also have like the similar kind of issue. All right, let's move ahead. Now I will give you the basic introduction of coordination compounds. Okay, so here the very first topic that we will discuss today is of simple salts. What is it? It is of the simple salts. Now, how are simple salts formed? So if I tell you about your basic neutralization reaction, so what do you do in this? You have an acid, right? You have an acid, you add a base, and it gives you salt plus water. This is your simple neutralization reaction, right, guys? Now let's take an example clearly. If we take acid as HCl and base as NaOH, then it will simply give you NaCl plus H2O. NaCl plus H2O. Now this here, NaCl, this is your basic salt. This is your simple salt. What is NaCl here? NaCl is your simple salt. It is your simple salt. Now, what is the deal with simple salts? It is whenever you dissolve a simple salt in water. What did I say? Whenever you dissolve simple salt. Dissolve simple salt in water. Now what happens when you dissolve NaCl in water? Let's look at the chemical equation as well. If you dissolve this NaCl in water, then it will completely dissociate into ions. It will dissociate into ions, right? It will dissociate into its constituent ions, correct? So your NaCl will break into Na positive aqueous plus Cl negative aqueous, right? In this form the salt will dissociate, Na positive plus Cl negative. Now the very first thing, what do we meant by this Na positive aqueous? It is like the when ion got dissociated, it is surrounded by water molecules, right? That's what I mean. So Na positive plus Cl negative is तरीके से it will get dissociated, right? So these are nothing but your simple salts. These are nothing but your simple salts. All right. I believe there is no doubt in simple salts till now. Correct? Let me know, beta, if there is any doubt in case of simple salts. We'll get it sorted. Okay? Next. So we discussed simple salts. Now the next thing which we need to discuss is addition compounds. What is it? It is addition compounds. Okay. Now what are addition compounds? Like it was noticed, like the simple salts. We just discussed simple salts, right? And we know like NaCl, KCl, right, K2SO4, these are quite stable, right? These are stable salts. And it was seen that even after being like so stable in nature, even then two different salts are combining together to give a new salt. It was seen that even though it is very, just give me a moment, guys. Give me a moment, please. Sorry. Yeah, where were we? We were at the addition compounds. Okay. So we have already discussed the simple salts, correct? Now we know that like your simple salts, KCl, MgCl2, these are already stable in nature, right? These are already stable in nature. Even then it is seen that two stable compounds combine with each other. Two stable compounds combine with each other to give a new compound. So now this was pretty difficult for people to understand, like why this is happening. Why is it happening? Like when the two salts are already stable, then why are they joining together? Why are they combining together to give a new compound? So that's what happens in an addition compound. I will let you know in the further sessions why it happens. Okay, why two stable compounds join together, why two stable compounds combine together. All right, that we will study in the further sessions. So yeah, now your addition compounds, they are of two types. Your addition compounds are of two types. Number one is double salt. What is number 1? Number 1 is double salt. And what is number 2? Number 2 is coordination compounds, जो हमको chapter पढ़ना है. So basically we are starting from the very basic stuff, like what are simple salts, फिर कहाँ से addition compounds आए, then what are the two types of addition compounds, right? Double salt and coordination compounds. And then we will study what are coordination compounds. Okay, so double salt and coordination compounds. What is this? This is your coordination compounds. Okay, so that's your double salt and your coordination compounds. Okay, let's move on to the next slide. So yeah, here you can see addition compounds are formed when stoichiometric amounts of two or more stable compounds join together. I told you already, when two stable compounds join together, they combine them with each other, then they are called as addition compounds. And we know that addition compounds are of two types, double salt and complex compounds. I don't know, right now it's visible. Double salts and complex compounds, or you can say simply coordination compounds. You can also say coordination compounds, one and the same thing. Correct? Now what happens in case of double salts? Now we will see what are double salts and what are coordination compounds. So in the first place, let's talk about double salts. In case of double salts, let me give you some example as well. Just a moment. When we were discussing addition compounds, so I told you that two stable compounds, they combine together to give a new, just give me a moment, guys. Just a moment. Just a moment. Something important. I will let you know. Just give me a moment, guys. Okay, I'll let you know. Yeah, it's done. Yeah, guys, so we are back. Yeah, and I was telling you that in case of addition compounds, if I tell you, say an example. Okay, if I tell you that we know KCl, that is potassium chloride, and MgCl2, that is magnesium chloride, right? If I say that KCl and MgCl2, we know that these two are already very stable salts, right? Even then, these compounds, I would say that they combine with each other in presence of, some molecules of water, that is 6 in this case. They combine together to give a new compound, that is KCl.MgCl2. KCl.MgCl2.6H2. This is the new compound which is formed. They combined together. Okay. Another example can be of which the barber uses after shaving. That is alum. Fitkari. It is called fitkari in Hindi. So your potash alum is another example. Now what is potash alum? It is an addition compound. You can say that if you have, what do we use in this? We use K2SO4 plus potassium sulfate you used and aluminium sulfate, Al2SO4 whole thrice, right? and aluminium sulfate in presence of, again, water molecules, 24H2O in this case. They also combine to give you potash alum. So your formula for potash alum is K2SO4 dot Al2SO4 whole thrice dot plus, sorry, it will be a dot here, not a plus, dot 24H2O dot 24H2O. Alright, so coordination compounds, this was the case of the addition compounds. Okay, when your two stable salts, you can see here, potassium chloride and magnesium chloride combine together, potassium sulfate and aluminium sulfate combine together to give a new compound. These two examples which I just discussed with you, these are your double salts. These are the example of your double salts. This is double salt, this is a double salt. Now you will be like, मैम आपको तो पता है कि ये डबल सॉल्ट है, हमें भी तो बताओ, आपको कैसे पता चला? Yes, Amar, it is also good for CBSE boards because see, we always start from the basics, correct? And every board, whether it is, even it is your JEE or NEET, your like basic chemistry or basic physics or any of the basic subject or any of the basic concept, it remains the same, right? So it is equally good in case of CBSE board, UP board, Tamil Nadu boards, for everything. As long as you are getting the concept, it is good for you. Okay, because the same thing is given in CBSE as well, same thing is given in ICSE as well. So there is no such difference. Even I would say, even if you are preparing for JEE or NEET, even then it is a good content for you. Okay, ठीक है? So yeah, as I told you, these are the example of double salts. Now you will be like, how do you know that these are double salts? So when you dissolve those salt, that is if you dissolve your potash alum in water, right? That was your K2SO4, Al2SO4 whole thrice in presence of water. So when you dissolve it in water, then a double salt, it dissociates, means it breaks into all of its constituent ions. It breaks into all of its constituent ions. That is, like, see, we took the example of your potash alum. Okay, let's take the example. So you know that it is your, let's use the different color. Yeah, so it was your K2SO4 dot Al2SO4 whole thrice dot 24H2O. Now when you dissolve it into water, then what happens? All of the ions, all of the individual constituent ions, they will get dissociated. Like when you dissolve your potash alum in water, then you will have K positive ions in the solution. You will also have Al3 positive aluminium ions in the solution, and you will also have your sulfate ions in the solution. You will also have your sulfate ion in the solution. And when you test for these individual ions, when you test for individual ions, when you test for the individual ions, the test will come out to be positive. Matlab, the test will be true, the test will be positive. That is, the test will be true. Okay, so you can say that when your salt completely gets dissociated after mixing it in water, So basically your salt, loses its identity. So here you can see the difference. The very first thing which is given here, that is those which lose their identity in the solution are called as double salts. All this stuff is about double salts. Okay, now your double salts, they are stable in the solid state. As I told you that they are stable in the solid state, उसमें कोई परेशानी नहीं है. They are stable in solid state, but they get dissociated into solution form, but gets completely dissociated dissociated into constituent ions when dissolved in water, in H2O. Alright, so that's your double salt. Cool, guys. That's nothing but your double salt. So you can see here, those which lose their identity in the solution, they are double salt. They exist as such in crystalline state, right? Powdered form में होते हैं, crystalline form में present होते हैं. When dissolved in water, these dissociate into ions of their individual components. That's just we discussed in here as well, and in the example as well, correct? So they will get completely dissociated into the individual components. As you can see, K positive इधर अलग हो गया, Al3 positive अलग हो गया, SO4 negative अलग हो गया. Alright, so when dissolved in water, these dissociate into ions of their individual components, and in the aqueous solution they give the test for all constituent ions. I told you na, if you test for individual ions, test will be positive. Okay, that is the case of double salts. Let me know, beta, whoever is here, if you have any doubt till now. Let me know, bache, if it's okay till now. Chetna, Naitik, Amar, is it okay, bache? I believe yes. Then we can move on to the next slide. So here you can see that your double salts are the addition molecular compounds which are stable in solid state. We discussed this, but dissociate into constituent ions in the solution. Example is Mohr's salt. Okay, Amar, that's great, beta. Example is Mohr's salt. Now this is a very famous salt. You will, in your chemistry practicals, your teacher provides like proper experiment by showing you when you dissolve your Mohr's salt in water, then it gets dissociated into all of the individual component ions, and when you test for those individual ions, it comes out to be positive. Okay, so this Mohr's salt is a very important example when it comes to your chemistry practical. Since now everything is online, so might be the case you haven't watched it live, but one thing that you can always do is go on YouTube and search whatever you want to. Okay, this is just my personal suggestion to you. All the practicals which are in your syllabus, at least, because since you are you are studying now online, right, as per your school curriculum, so go to YouTube and watch all the chemistry practicals on YouTube. Okay, You will have all the salt analysis, all your setups, all your titrations. You can watch it at least online, so at least you know how it works. Okay, you might not do it like in real, like physically, but at least watch it so that you know, okay, yeah, there is a pop sound when it burns, or there are like fumes when it burns. Okay, so at least see it. At least that's my personal suggestion to you. And I will wait for all of you beta in the special class that is free for everybody. The time for special class is 5:15 to 6:15 for class 11, and 6:30 to 7:30 for class 12. So you guys can at least come to the special sessions, and you can unlock the free live class by my code, that is Kirti, KIRTI S live. Okay, so you can reach out to me by, like, you can use this username, and you can reach out to me on Telegram or Unacademy Messenger. My username is Kirti underscore. Please note that this is an underscore. Kirti underscore Sharma 1223. This is my username for Unacademy, for Telegram, for Instagram. You can find me by this username, and we can get connected. If you have any doubt, whether like in Plus subscription or like Unacademy or any concept, then you can reach out to me by this username. Okay, I'll send you my group. I'll send you the link of my group as well, on which I post all the further classes, whether it is Plus or special or YouTube. Okay, so yeah, let's move ahead to complex or coordination compounds. Now these are kind of opposite of double salts. Now these coordination compounds, these are also addition compounds. That is, two stable compounds are combining together in order to form coordination compound. But when you dissolve a coordination compound in water, it does not get dissociated into all of its constituent ions. It does not get dissociated into all of its individual components. Instead, it gives you complex ion. What does it give you? It gives you complex ions. So when dissolved in water, they don't dissociate into ions of their individual components, but instead they give you what? They give you complex ions. They give you what? They give you complex ion. So like if I give you example that ferrocyanide, that is FeCN whole twice, a stable compound, it combines with another stable compound, that is KCN. That is KCN. Now these two stable compounds join together. Okay, this is the compound, and when you dissolve it into water, when you dissolve this into water, it gives you 4K positive. एक तो मिला पोटेशियम आयन, 4 मिले आपको पोटेशियम आयन. इसके साथ what did you get? You get a complex ion. Now your complex ion is something like this: FeCN whole 6, and here 4 negative. Okay, I will let you know like why it get dissociated in this manner, and how can you write this like something in square bracket and another thing in normal brackets. Like, how did you do it? Don't be in a panic, don't be in a rush. It is just an example to show you that this is a complex ion. I will let you know about everything: what is central metal atom, what is coordination sphere, what is ligand, what is coordination number, what is oxidation number. We'll discuss everything. It is just a minor example to show you that something like this, since it is like when you see it, you see that it is something complex, kuch alag hai, right? Kuch difficult sa lag raha hai, but hai nahi. So this is something complex, and that's your complex ion. Okay, it is nothing but your complex ion. All right, Amar, Chetna, let me know beta if you understood till now. Then we will start with the, like, we will move on to the next slide. Okay, my health is a bit weird today. Okay, so here you can see the difference between double salts and coordination compounds. Sometimes in your subjective exams, the examiner give you the straightforward question: what are additional compounds, what are addition compounds, and differentiate between double salt and coordination compound. This you get as a 3-marker question sometimes in your subjective exams. In your subjective exams, you give the, you get the direct question. Okay, just give me a moment. That's great. That's great, Amar, if you have done this. But still, let me know, like, if you have any doubt, whether you whether you get the concept, or like you feel like if something is missing, or any improvement, then let me know, right? If you feel like maza nahi aaya types, then let me know. Yeah, now I'm a bit fine. I don't know how and why I had food poisoning in the morning, and I was quite hospitalized, and the doctor gave me 3 injections. It was really painful. So yeah, now a bit fine, and I had to cancel the session which was in the afternoon. Now I'm taking this session. Okay, Shahil. Okay. Ra. Okay, let's move ahead. Now, you can see here exactly the difference between double salts and coordination compounds. Okay. So yeah, these exist. Please read this, Amar. The differences which are given on the screen. Please read all of them. Yeah. My facial expression was exactly same. Ditto. Okay. So yeah, these exist only in solid state and dissociate into constituent species in their solution. They lose identity in dissolved state. We have covered this. Their properties are essentially the same as those of constituent ions. We have covered this. In double salts, the metal atom or ion exhibit normal valency. Now your this concept of primary valency, secondary valency, what is valency, we will cover it in the next slide. Okay. Now your coordination compound, you can see that they retain their identity in the solid as well as in the solution state. And coordination compounds do not lose their identity in dissolved state. Their properties are different from those of their constituents. For example, if you dissolve K4FeCN6 in water, that is potassium ferrocyanide, then I showed you that it does not get dissociated into its constituent ions, right? वो Fe2 positive, Cn negative में Cn negative में dissociate नहीं हुआ, correct? So that is why it is a complex, or you can say a coordination compound. All right. So their properties are different from those of their constituents. For example, K4FeCN6 does not show the test of Fe2 positive and Cn negative ions. Okay. And in coordination compounds, the number of negative ions or molecules surrounding the central atom is beyond its normal valency. We will discuss the concept of valency now. Now the next thing which we are going to discuss is Werner's theory. Now Werner's theory, why Werner uncle's theory is important. Now why only, like when it comes to coordinate compounds, your coordination compounds, so people were not people did not know like how and why two stable compounds are joining together, why two stable compounds are combining together to give a new compound when they are already stable. And even when like two compounds are joining, why only like some certain compounds only, why not all the compounds, and why are their structures different? So these were the questions, okay, like why is it happening? And our Werner uncle was the very first person who gave an attempt to explain the bonding of the coordination compounds, like why these compounds have different kind of bonding. We will see why the bonding is different, we'll deal with it. Okay, so like he was the very first person who tried to explain why such kind of bonding exist in coordination compounds, in coordination complex. Okay, so you can see here Werner's theory, जो भी Werner uncle ने कहा, it was his theory. So it was the first attempt to explain the bonding coordination complexes and to answer the questions such as why two stable compounds join to give several new compounds and why are their structures different. These were the questions. So now according to Werner's theory, he said that there are two types of valencies. One is a primary valency. One is a primary valency. And the second one is a secondary valency. The second one is secondary valency. Okay. So yeah, here in Werner's theory, he said that metals exhibit two types of valencies in the formation of complexes. Now primary valencies, जो primary valency होती है according to the Werner uncle, it is simply the oxidation number. It is simply what? It is simply the oxidation number. I have told you beta in the redox reaction, you can watch the session which is for redox reaction. I have made you understand all the rules for like how to calculate oxidation number. That I'm not going to start in this lecture. So like if your say metal is Cu2 positive, or say it is Fe3 positive, or say it is Fe2 positive, or say it is CO2 positive. So in these you can see that the charge simply which is present on them, it is their oxidation number. In this case it is +2, +3 in this case, +2 in this case, again +2 in this case. So these are nothing but oxidation number, right? These are nothing but oxidation number. Simply इस oxidation number को Werner uncle called it as primary valency. What did he call them? He called it as primary valencies. And these primary valencies, since metal के लिए आप oxidation number निकाल रहे हो, so it will be like plus positive charge होगा. So that is why your primary valency is only satisfied by anions. Your primary valency is only satisfied by anions. That is those which have negative charge. Okay. So that is why these are ionizable and these are non-directional. We have already done in the in class 11 that ionic bonds are non-directional. Ionic bonds are non-directional. Correct? We have done this. The ionic bonds are non-directional. How can you say that? See, if this is the cation, all right? So it doesn't matter to it like in which direction the anion is present. The cation will simply, attract the anion and they will form a bond. But when it comes to a coordination bond or covalent bond, the direction matters, right? That is why you define geometry and shapes in case of coordination, as well as covalent compounds, right? Whether your shape will be octahedral, tetrahedral, square pyramidal, square bipyramidal, you do that. So your primary valencies, that is your oxidation number, since it is like oxidation number for metals, so it is satisfied by anions. That's why these are ionizable and they are non-directional because of ionic bonding. We know that ionic bonds are non-directional in nature. Cool. Next is like about secondary valency. Secondary valency is nothing but coordination number. Now your coordination number is simply if your metal atom, okay, your central metal atom is surrounded by how many species, कितने लोगों ने आपके central atom को घेरा हुआ है, how many species are surrounded, ठीक है, to the central metal atom or ion, these surrounding species which donates electrons. I'm telling you already that they donate electrons. They are called as ligands. What do you call them? You call them as ligands. Now these are non-ionizable and these are directional. So that's why you will decide a geometry for them. Yes, Pragya, I definitely remember you, beta. I just looked at the comment like in a while, in like some late hours. But yeah, I definitely remember you, Pragya. I remember Pragati as well. I remember all my students, okay? You don't need to worry about that. So yeah, your secondary valencies correspond to the coordination number of the metal atom and are satisfied by ligands, okay? So like, if I tell you that this is your central metal atom, so if your cyanide ने, cyano group ने ऐसे इसको घेरा हुआ है, now here your CN, it provides both the electrons, okay? So that is why this is a coordinate bond, okay? That's why you say that it is a coordinate bond, because both of the electrons are donated by cyano group here, all right? So yeah, if I give you examples, okay? If I give you example, say the first one is CONH3 whole 6 Cl3. So if we want to know like what is primary valency here and what is secondary valency here, so I told you that primary valency here, this is your central atom or ion, this is your central atom or ion. If it is neutral, then it is ion, then it is atom. If it has some charge, then it is your ion, okay? Now here your cobalt is central metal atom or ion, right? I told you that primary valencies are satisfied by only anions. We know that ammonia is neutral, So what is the anion here? Chlorine, correct? So as you know that chlorine के ऊपर Cl negative exist करता है. On one chlorine its charge is -1. So for 3 chlorine it will be -3. So in order to balance it, cobalt will have +3 charge, and that is why you can say that its oxidation number, or you can say primary valency, according to Werner uncle. Its oxidation number or primary valency is simply +3. How much is it? It is +3. And when it comes to secondary valency, or you can say coordination number, if we talk about secondary valency or coordination number, so you can see that cobalt is surrounded by 6 ammonia molecules. Okay, so here your coordination number is 6. Okay, oops, a gadbad. My pen is now not with me. Right, Amar, you are right. I lost my pen. Okay, oopsie, a bit choti si gadbad ho gayi. All right, then okay, this is simply your Werner's theory. You can look at, so you can see here we will wind up on Werner's theory. So you can see that the postulates of Werner's coordination theory were actually based on experimental evidence rather than theoretical. And although it was Werner's theory successfully explained the bonding, but still it had some drawbacks. And the drawbacks were that he could not explain why only certain elements form coordination bonding, and it does not explain why the bonds in coordination compounds have directional properties, and he could not explain the color, magnetic and optical properties. So these are the drawbacks of Werner's theory. All right, now it's time to let you know, bache, follow this on the link is given to you in the description box. Follow so that you will get the notifications. Here you can see the offer which is going on, that if you get the subscription for 12 months, you will get additional 3-month subscription. And another deal is, if you get the subscription for class 11, you will get class 12 subscription for free. Okay, so these are the batches. Mavericks batch you can see which is going on, and here you can see the features of Unacademy subscription. Since there is again an outbreak of COVID, so you can learn live with the top educators of India, with all your doubt solving, answer writing session, mentorship, all the material is provided to you. Yeah, yes, Amar, now I am okay. Okay, Pragya, beta, dhyan rakho, because this viral and it's freezing here. So take care of you and your family. Here you can see that these are the subscription plans. If you subscribe for a longer period of time, it will be more economical for you. My code is Kirti S Live. You can simply use this code to get an additional 10% off. Okay, these are the existing batches. You can see, you know already how to watch special class. Just simply download basic informations, fill karne, and then go for ISC category. Okay, so that is it for the day. Unacademy, let's crack it. Bye bye bacha party. It's been a long session for me. That is it for the day. See you in the next session, and I hope that you guys are vaccinated. Okay, if not, then book your vaccination slot right now and get your vaccination done. Okay, so bye bye guys, see you in the next session.